With the quiz coming up, I'm going to go over this review for you. So if you're at home and you have any questions, just fast forward through the video and look at any of the problems that you need to look at. So sorry, I didn't have a PDF version of this, so I couldn't just have a blank version. I had to take a picture of it, but it's fine, doesn't matter. Let's start by looking at number 1. So Mina's catering service is organizing a formal dinner for 280 people. The hall has 2 kinds of tables, one that seats 4 people and one that seats 10 people. The hall can contain up to a total of 52 tables. Let X represent the number of 4-seat tables and Y the number of 10-seat tables. Write and graph a system of inequalities that could be used to determine the possible combinations of tables that could be used for the event so that there are enough seats for the people. So the way this is worded, I can see it being kind of confusing at the first part of it being the 280 people, because it kind of says that there's going to be exactly 280. And that's true, that the formal dinner is for 280 people, I guess, in total that are invited, but we have to make sure that we can fit all 280 people in there. So for 280 people, I think. Yeah, for 280 people at the most, I would assume. So our inequalities are, we're going to have 2 variables. We're going to have an x variable and a y variable. So an x variable, we'll use that to represent, I'm going to use black. The red doesn't show up too well. I think the black will look just okay. So the x variable will represent the small tables, the ones that 4 people can sit at, and y will represent the large tables, the one that 10 people can sit at. So for our inequality, we have, referring to the number of people, 280 people in total, the smalls table seat 4 people, the large seat 10 people. So for our inequality, we would have 4 times x. What this says here is that we have 4 people per small table, right? X is small table, as we mentioned, and 4 times x represents that there are 4 people per small table. So we add that to 10 times y. That's 10 times 10 people for every large table, right? Y is large table, and large tables fit 10 people. Now this is less than or equal to 280 people in total, because we were able to fit 280 people. So now we need a second inequality. And our second inequality just refers to the number of tables, only the number of tables. So this inequality that I wrote, just to backtrack a little bit, refers to people, right? 4 people for the small table, 10 people for the large table, and then 280 people in total. It's all about people. But the second inequality is just about the tables. So x represents small tables again, y represents large. So our inequality is that we have to have a total of 52 tables, is the number of small tables, just x, plus the number of large tables, just y, has to be less than or equal to 52. Because we're looking to, the hall can contain up to a total of 52 tables. So we can fit 52 tables at max. So we have our 2 inequalities, and now we need to graph them. And my approach would be, instead of trying to do slope-intercept form, because these numbers are so big, and our graph does not go up by ones, it's going up by tens every time, 10, 20, 30, 40, etc. To do it using the, finding the x and y intercepts. So when it comes to, I'm going to do this off over to the side, just so I have some room. So I would recommend you do it on the back. But 4x plus 10y is less than or equal to 280. So to graph this line, I'm going to find the x-intercept and the y-intercept. So the x-intercept is solving this inequality, but plugging in 0 for y. So what this is doing, essentially, is it's saying, hey, if we didn't have any large tables, no large tables at all, and we just had a bunch of small tables, what is the most we can fit as far as small tables go? How many small tables would we need, right? So we're just ignoring the y in general because we're assuming it's 0. We want to find the total number of small tables without having any large tables. We want to find the biggest number we can. So we do this, we would divide by 4, and we would have x is less than or equal to 70. So that would be my x-intercept. For the y-intercept, we do the same thing, but we plug in the 0 for the x, right? We're trying to solve for the y value. So 4x plus 10 times y less than or equal to 280. Well, we're going to plug 0 in for the x, because what we're essentially doing is we're trying to find out if I don't have any small tables at all, what's the biggest number of large tables I would need to hold 280 people. So if I don't have any small tables, then I'm going to do 10 divided by 10 here, and we're going to get y less than or equal to 28. So my y-intercept is 28, and my x-intercept is 70. So we're going to plot those points on our graph. Y-intercept is 28, which is going to be, let me zoom in on this. It's going to be about right here, just a little bit under 30. And then my x-intercept is 70, which will be right about there. Ooh. I think I broke. Oh, there it goes. Okay. So I think I broke it. Oh, apparently I broke it right only in that spot. Okay, I'm confused. It's going to work. All right, maybe I zoomed in too much. All right, but there you go. You have the y-intercept there, or the x-intercept at 70. So we just connect that with a line as best we can. Okay. And we can have only 280 people in this, so we're going to shade below this. So we're going to shade, I'm going to use a highlighter. Let's use the pink highlighter, I guess, just for the sake of it. Okay, I broke it. Oh, I can't. Oh, I'm writing. Oh, I can't write on top of this for some reason. Okay, I can't actually shade it in unless maybe I just do it the old-fashioned way. Yeah, like this. So I would shade this part of the line in. And then we graph the other inequality. So the other inequality was x plus y less than or equal to 52. Okay, my pen's definitely not working the way it's supposed to. So I apologize for the bad handwriting that's going to come out of this, but I just want to get through this video for you. So it's supposed to be a plus. There you go. So again, if you employ the same strategy, you plug in 0 for x and you solve for y, then what we have is just y less than or equal to 52. And if you do the same thing for x, right, you just plug in 0 for the y and you try to find the x, then you're going to have x less than or equal to 52. So this tells you the x and y intercepts for that line. So that's going to be 52. Let me use a different color. Let's use the purple. 52 x-intercept, 52 y-intercept, and then just graph the line. And we're shading below this line as well. So everything that's in the overlapped region is going to be our solution set. Okay, so number 2. Graph, was there another question on that? Oh, it says, oh no, yeah, we're good. We graphed it. All right. Number 2, graph the system of linear inequalities. So my first equation, my first inequality is y less than negative 3x plus 2. Now, both of these are already in mx plus b form. Okay, now it's working fine. Okay, so that's good. I don't know what was wrong with it before. So what that means is that we know that because it's in the right format, that the plus b number, which is 2 in this first inequality, is my y-intercept. So on the y-axis, I'm going to go to 2, plot my first point. And then my m value, which is negative 3 in this case, is my slope. So my m value is negative 3, which is the same thing as negative 3 over 1. So this tells me that my rise is negative 3, which really means down, and then my run is 1. So I'm going to go down 3 and right 1, puts me right here. And then I go down 3 and right 1 again, and I go right here. So I'm just going to plot these points to complete my line. So now, because our inequality symbol is just less than and not less than or equal to, it's going to be a dotted line. There you go. And imagine that was straight. That'd be great. So remember, if it's just less than or just greater than, it'll be a dotted line. But if it's less than or equal to, greater than or equal to, it'll be a solid line. Just something to kind of remind you. Now, we still need to shade this in. This is y less than. So less than means below. So it's kind of hard to tell which side's the bottom of this line or which side's the top, because it kind of looks more left and right than it does up and down. But if you pick any point, So let's say I pick this one right here. I'm putting my pen above it. And I'm supposed to shade below, so I just go down from that point. Okay, and you can pick any point. If you pick this point, you go down. This point, go down. That tells you can clearly see what side that line of you're supposed to shade. The side is really sort of that left side. We would shade all of this in. Now, I'm going to do that in a second, but I don't want that black ink to kind of get in the way of me graphing my next line. So I'm going to graph my next line real quick, and then I'll shade in last. So I'm going to switch to purple. And the second line. So same format, mx plus b. The plus b value is -1. So our first point is going to go at -1. And then my slope is 4. So my slope being 4 is really 4 over 1. So I'll go up 4 and I'll go over 1. Oh, not down. Go right. Go running. So go count up 4 and over 1. It's going to put that point there. And if we fill that line out, we'll have a point down there. So because this inequality has the equal to part, it's greater than or equal to, we will shade, or we will do the full line rather than the dotted line. So because it's y greater than, we would shade above the line. So if you're wondering what's above the line, go to any point. So let's take this point, for example, and then draw a line straight up. If you draw a line straight up, you're going to be on this side of the line, which means you would shade in that side of the line. And now for the black line, let me go back and shade that in real quick. I hope yours looks better than mine. I apologize for mine not looking good, but I didn't realize that the highlighters weren't going to work on this picture. But anyway, we shaded, remember, this part of the purple line or the black line. So it's a little messy, but hopefully you get the idea and you can make yours look a little bit better at home. So the overlapped region is sort of this this region. It's kind of hard anyway. You'll figure it out. Okay, number 3. Actually, if it's okay with you, I'm going to do number 4 first, and then do number 3. I'm doing number 4 first because I'm going to put number 4 on this graph, and then I'm going to erase it and then put number 3 on this graph, only because I don't have a graph to put number 4. Now, for you guys at home, you can always just flip your paper over and use the back side of this graph. You can kind of see through the paper and then use this graph, but on the opposite side, if that makes sense. You can sort of trace over it. That's how I would do it. But I'm going to do number 4 real quick, and then I'm going to go erase it and do number 3 on this graph. Okay, so number 4, we have our y-intercept at -4. So we're going to have a y-intercept at -4, and our slope is nothing. Well, it's not nothing, but you don't see a number, right? It's just x. But just x really means 1x. So that's telling me that the slope is really 1 over 1. So we're going to go up 1 over 1 and fill out our points. And because it's y greater than or equal to, it is a solid line. And because it's greater than, we would shade above that line, which will be here. And I'll do that last, but I don't want it to get in the way of my next color. So the other line, its y-intercept is -8, which doesn't really fit on this graph. So maybe on the backside, you can make it go down a little bit further. So -8 for me, 5, 6, 7, 8 would be about here. And then I would go down 2 and over 1. The slope's -2. So it'd be down 2 and right 1. Obviously, I've already ran out of room going down. So what I'll do is I'll just go up 2 and left 1. Do the opposite. Remember, this would be down and right normally. But because we can't go down and right, we'll switch it up. We'll go up and left. And it'll be the same thing, just the opposite direction. So up to left 1 would be right here. Up 2 and left 1 would be here, 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 and there, and there. And then this line would be a solid line as well because it's y less than or equal to. And we would shade below that line because y is less than, y is below that line. So for the purple line, we would shade this part of the graph. And for the black line, we would shade above it, which is this part of the graph. So they overlap kind of in that bottom left corner. All right, now I'm going to erase it, and I'm going to do number 3. So number 3, we have y-intercept is -5. So we're going to point at -5, which is right here. And then our slope is 3. Remember, that's 3 over 1. So that's rising 3 and running 1. So go up 3 and right 1 puts us here. Up 3, right 1. Up 3 and right 1. We have our line. Now, because it's less than or equal to, that less than or equal to means we have a solid line. And because it's less than, it's going to be below the line, which will be this side here. But I'm going to shade that in. I'll come back and shade that in last. All right, for the purple line, we are doing y greater than or equal to -2. Now, there's no x value. So what this means, it's just going to be a straight line, a straight horizontal line through the y-axis at -2. So the y-axis is -2 is here, and we're just going to draw a line straight through it. And it's a solid line in this case because it's greater than or equal to. Okay. So because it's greater than -2, we would just shade above -2, above that line. So it's going to be this region all up here. All right, so now I'll go ahead and I'll shade that black line in again. Black line will be below the black line, so it's going to be this. So you can see that region on the right-hand side where they overlap. Very sloppy, I know, but it is what it is. And then number 5 takes the most math to actually work out. Number 5, you have to rearrange the inequalities in the slope-intercept form. So 6x plus 8y is greater than or equal to 24. We're going to solve this for y and then have it in slope-intercept form to graph our line. So to do this, we have to move the x term, we have to move the 8 in order for us to cancel them out and have just the y by itself. So to cancel out 6x, we would subtract 6x. Now we're doing this on both sides to keep the equation balanced, but look what happens. 6x minus 6x is 0, right? It goes away. So that's going to be 0. Then we bring down the 8y, and then we bring down the stuff on the right-hand side, which is 24 minus 6x, which is really just negative 6x plus 24. So we have 8y is greater than or equal to negative 6x plus 24. So divide by 8. And we have y greater than or equal to, now pay attention to this, negative 6 over 8 actually reduces negative 6 over 8. You can divide both of these by 2, which turns it into negative 3 over 4. That's going to make things a little bit easier for us. Negative 3 over 4. And then 24 divided by 8 becomes 3. So now this is ready for us to graph. However, before I graph it, let me go ahead and rearrange the other inequality, which is negative 3x minus 4y greater than or equal to 18. So do the same process, right? We have to get the y by itself, so we're going to get rid of the negative 3x. We're going to get rid of this negative 4. So first, the negative 3x. We'll cancel it out by adding 3x. Negative 3x plus 3x is 0. Therefore, when I add them up, it'll cancel out. That makes 0 minus 4y greater than or equal to 3x plus 18. So it's still a negative 4y, keep in mind. So now to get rid of the negative 4, just like we got rid of the 8 up here, we're going to divide. So we're going to divide by negative 4. Now you have to be very careful about what happens here because lots going on here. Because we divided by negative, the sign is going to flip over. Not only that, but 3 divided by negative 4 is really the same as negative 3/4. So that negative doesn't have to stay on the bottom. You can actually put the negative with the 3 instead, and it's the same number. So think of it as negative 3 over 4. And then 18 divided by negative 4 is actually going to be a negative 4.5. So now we're ready to graph. So let me do this one in purple real quick. So the y-intercept is negative 4.5. So we'll go to negative 4.5 on the y-axis. And then our slope is down 3 and right 4. But of course, we don't have enough room to go down 3 and right 4. So we're going to do the opposite. We'll go up 3 and left 4. All right, so up 3, left 4 puts us right here. And that's the only other line that I can put on there. So, or the only other point I can put on there. So the line is going to be a solid line, and we're going to shade below that solid line. So we're going to shade this region here. And it's a solid line again because our inequality symbol, y less than or equal to, is got the equal to part, right? If it was just less than, it would be a dotted line, but since it's less than or equal to, it's a solid line. And because it's also less than, it's the reason why we shaded below the line, not above. So now the black line, its y-intercept is positive 3. And its slope is, again, down 3 and right 4. So we actually can do that on this one. We can go down 3 and right 4, put our point right here. And we can also actually fit in one more. If we go up 3 and left 4, we can put that point right there. And for the same reason as the last inequality, it is a solid line. And in this case, y is greater than, so we would shade above. And now describe the solution set, right? It says describe the solution set. Well, there is no overlap region here, and there will not be an overlap region there because the lines are parallel. So that tells us that there are no solutions, that the solution set is empty. There is no overlap region. There is no solution. And that is it for the review. I hope you guys good luck on the quiz tomorrow. Hope you do well. If you have any other questions, we'll answer them in class. Let me know. See you guys later.